Hello, everyone. In this unit, I said that we were going to be investigating probability and statistics, and this continues our statistics sections, as the first one was mostly an overview of vocab. In this one, we actually are going to start to do some calculations with the data. And so as a warm-up question, I'm just going to ask you some things that they expect you to know coming in from prior classes. So here's the question. Let's say test scores for a history test are shown below. What is the mean, median, mode, and range for this data set? This question is not in the note packet because it's just me checking in to see if you remember what the mean, median, mode, and range are for a data set. I'm going to help you out a little bit. I'm even going to rearrange the data set from highest to lowest. That might be a sigh of relief for some of you. Now, see what you recall. Can you state what the mean, median, mode, and range for this data set is going to be? So pause the video now for maybe a minute or two until you've given it a go. Come back and see how you did with some prior knowledge that they expect you to have coming into this section. So pause the video now. Okay, so the mean, median, and mode. Well, we should probably define them at first. The mean is the average value. So how do you find the average? You add all the numbers up and you divide by however many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it looks like, if I counted right. So I'd add them all up, divide by 11, that's the average. The median is the middle value. So you need to find where the middle is, ranking them from highest to lowest, find the middle value. So I think in this case it's going to be the 83 because then there's going to be 5 above and 5 below. The mode is the most frequently occurring result, and the range is the spread of the values. It's how far apart the high and the low are. The mean in this case turns out to be 77.5 if you add them all up. The median we said already, that was 83. The mode is the most frequently occurring, and if I look which one occurs the most, it's the 91. The 91 is the only one that repeats, so 91. The range is how far apart the high and the low are. 95 minus 40 is 55. So those are some ways that those are some of the first calculations we do with data. That's kind of more of a middle school introductory one. Today we're going to see how we extend on that in higher levels of statistics. So to start, this is actually where the note packet starts. Why do we even collect statistics and samples? So before we go computing values and numbers with them, why do we collect statistics and samples? The reason why is because we want to know something about the population. We call that value the parameter. The parameter is the measure that describes a characteristic of a population. It's the value that we want to know, but usually the population is so large that we can't calculate it. In the prior lesson, I talked about if you worked for a clothing company, you might be interested in the average height of all males in the US. That value, maybe it's 5'10". That value, if we could measure every single male in the US, the value of the average height, that would be the parameter. The problem is we can't measure every male in the US. It would take too much time and it's going to constantly be changing. So what we do instead is we do a sample. Hey, look at that right there. It says if we wanted to know the average height of males in the US, we would have to measure every male. Let's say it turned out to be 5'10". That value would be the parameter. Because we can't get at that, we do a sample instead, and the value that we get from the sample we call the statistic. The statistic is the measure that describes a characteristic of the sample, which we're using to estimate the parameter. We're saying it's probably pretty close to the parameter if we sampled correctly. So maybe instead of sampling every male in the US, we randomly sample 100 from across the nation and find that the average height is 5'9". That value of 5'9" would be the statistic. We hope it's close to the parameter, but technically we never know. And that's why there's a whole field of statistics to say how good we feel about this value being close to the true unknown value that technically maybe only like God knows. So that's parameter. It's the value for the population. The statistic is the value for the sample. You can remember because parameter starts with P, so it's the value for the population. The statistic starts with S, just like sample. It's the value for the sample. Let's work a scenario so you can kind of see it in action. So at a local university, a random sample of 40 scholarship applicants is selected, and the average GPA of those 40 applicants is calculated. The sample are the 40 applicants selected. The population would be all scholarship applicants. The sample statistic would be the mean, the average GPA, because it's the sample, it's for the statistic, it's for the sample, it'd be the mean GPA of the 40 selected. The population parameter would be the mean GPA for all applicants. It would be the average GPA for the population, which would be all applicants in this case. Maybe that mean GPA is 3.6 here, and here maybe it was 3.5. We don't really know, but it's the actual value, whatever that average GPA would be. Okay? I'm gonna have you try. So a random sample of 30 nurses is selected from all hospitals in a 10-county area, and the median salary is calculated. What was the sample? What's the population? What's the statistic? And what's the parameter? Pause video now and give this a go. Unpause it once you've tried. So here we go. Let's do it. I think I can type here. Yes, I can. Okay, so the sample would be the 30 nurses that were selected for the study. The population would be all nurses in the 10-county area, because only those in the 10 counties could have been selected. It doesn't say nationwide, it's only the nurses in that 10-county area is what we're interested in studying. The sample statistic would be the median salary of the 30 nurses selected. The population parameter would be the median salary for all nurses in that 10-county area. Maybe that median salary for the 30 selected is something like 55,000. Maybe the population, if we actually included everybody, was 58,000. Hopefully that statistic is close, because it would take too much time and money and resources to survey everybody, so we only do a portion, a sample. Once we have values, then we start to do some calculations with them. So this is where we actually start to compute. So here's a scenario that we're going to use. An NFL team, so a football team, is debating between two running backs. Those are players who get the ball, they hand off, they get a handoff from the running back, and then they try to gain yards. So between two running backs to draft for their team, the number of rushing yards from the past 5 games is shown below. Which one should they pick? And obviously the higher the number, the better, because they got more yards for their team. So option A has the following results from the last 5 games that they played. Option B has the following 5. You can see for yourself. What type of calculations do you think that people do with it? Well, I'd hope you would have guessed the first thing they probably do is get an average. Yeah, they want to know what's typical. The next thing they want to know is how consistent they were. What's the variability? Well, we kind of talked a little bit about this before in the warm-up. One way of measuring the variability is you could always do the range, how far apart the high and low is. The downside of that is it doesn't tell you what was going on in the middle. Were they all clumped in the middle? Were they really all towards the ends? So the range is really a beginner way of calculating variability. There's another way that we're going to do variability, and that is going to be what we call calculating what's known as the standard deviation. Deviate means to stray from typical, and typical in this case is average. So the standard deviation is the calculation of how the data deviate from the mean. And there's a formula that in statistics we use to calculate it. It's shown below. You're only going to have to do this once by hand in the note packet, but it's actually a very intuitive formula once you kind of hear me describe why we do it. And then I'll show you how the calculator will do it for you. So the steps are right here as follows. You can read them for yourself. They're in the book. I'm going to talk through these here in just a moment. The standard deviation symbol is this symbol right here. I don't know what it looks like to you, because to me, I know it is the Greek letter sigma. But that little symbol right there, the reason that they chose the Greek letter, so just like we have an alphabet, the Greeks had an alphabet as well. And this one right here, the lowercase s, is that symbol right there. And that's what they chose for standard deviation, because standard deviation starts with s. So that's the Greek s, Greek lowercase s, called sigma. Now, what is this formula doing? Well, if I want to find how consistent the data set is, this is how we can do it. Well, the first thing is we need a symbol for average, and that is this symbol right here. An X with a bar over it in statistics is used for to communicate average. I want to know how far each value is on average from the average. That's a lot to take in, so let's look at what the formula is doing. Well, the first thing it does, so x1 is the first data measurement. So I want to find how far it is from the average, so I subtract. If I want to know how far it is from the average, I subtract. And then I want to know how far the second point is from the average, so I subtract its value from average as well. Then I want to do it for the third, the fourth, all the way up until I've used all n. N is the total number of points in my data set. I've done it for all of them. I've subtracted to find how far each measurement was from the average. Well, some are going to be above and some are going to be below. That means some are going to be positive numbers if they're above the average, and some are going to be below if they're below the average. They're going to be negative. Well, positives and negatives are going to cancel each other out to always make 0 if I'm always doing it from average, because half are above and half are below. That's the definition of average. If I don't want this to cancel out, then what I can always do to make a number positive is I can square. So that's what we do. We find how far it is from it, the average. We square so that all the numbers are positive. And then how do I find an average? I divide by the total number of points in my data set. And then the last thing we need to do is we need to undo the fact that we squared. So once we get my final number, I take the square root of it. That's the theory. You can read the steps. We're going to work through one of them by hand. So we're going to find the standard deviation, how far on average were the data points in this data set from 83. So here's the standard deviation for running back A. Let's use the formula. So the standard deviation is equal to the square root. Here we go. The average value is 83. And so the first thing I do is 83 minus x1 is the first data point, 75. So 83 minus 75. And then I would square it. I'm just going to write it all out right now, though. Then 83 minus the second one is 80. And then I square it. Plus 83 minus 85. Square it. Plus next one. 83 minus 90. Square it. Plus the last one. 83 minus 85. Square it. And then I need to divide by how many points? Well, there were 1, 2, 3, 4, 5. So I divide by 5. Going down my list. So standard deviation, square root, going to simplify. 83 minus 75. So the first data point was 8 away from the average. So this would be 8. And then we're going to square it. We're going to talk about why it gets squared here in a second, but it was 8, then squared, plus 83 minus 80. Well, that's going to be 3 squared, plus 83 minus 85. Well, that's going to be negative 2 squared. And that's why you see we're squaring it, because some are going to be positive and some are going to be negative. Plus, this would be negative 7 squared plus negative 2 squared. Now watch, if I didn't square these, look, 8 and 3 is positive 11, negative 2, negative 7, and negative 2 is negative 11. If I don't square, these top are always going to add up to be 0, because half are above and half are below. And if I just want to talk about distance away from the average, distance is always positive, so I'm going to square all those values. That's what will make them positive. Then I divide by the fact that there were 5 measurements. Need to simplify some more. So here we go. This will be 8 squared, 64. So 64, then plus 9, plus 4, plus, extend my square root, 7 squared is 49, plus 4, all divided by 5. Grab a calculator, and I type in 64 plus 9 plus 4 plus 49 plus 4 divided by 5 is 26, and the square root of 26 is just above 5. It's 5.1. And we're measuring yards in this case. What that means is, on average, running back A was usually no more than 5 yards away from his average game of 83 yards. So that's pretty consistent. He was usually no more than 5 yards above or below is what we're saying. We'll see more of that here in a moment. That's how I can get the standard deviation for A, 5.1 yards. To get the standard deviation for B, we are going to use the calculator. So instead of doing this out by hand again, I'm going to use the calculator, and I'll show you how to do that. So you grab your calculator, and I'll also show you how you can use Desmos if you don't have a graphing calculator at your disposal, but I'll show the graphing calculator first. What you do is you hit the stat button, you choose edit, we're going to enter the values in our data set. If there's stuff in there, you can go to the top, hit clear and enter, go to the top, hit clear and enter, and then you need to type your data set in. So it's 40, 120, 40, so 40, 120, 40. That's the first 3 games. The last 2 were 60 and 160. 60 and 160. There's his 5 games. Now once I have it entered, I hit stat again, but I don't edit. I go over to calculate and I choose option 1 variable. My only variable is rushing yards. My list is in L1. My frequency, you can just clear that out. Just hit delete. There's no frequent. We only have 1 list, so you can clear that out if there's something in there, and then hit calculate. And it'll run the calculation for us. There's the average right there of 84, and then the symbol we're looking for is right there's that sigma symbol, 48. So the standard deviation for running back B would be 48 yards. You see he is a lot more variable. He is not as consistent. He has a much greater spread. Some games he's 48 yards above, some games he's 48 yards below his average. So let's write down what we just found. The average for running back A was 83. And I should point out, look, when you did this, there's that average right there. So there's the average value, there's the standard deviation. And then this was, I think, 5.1. And this was 40, I wrote it down, 48. So here's the conclusion. Although B averaged 1 more yard per game, most teams would probably pick A because his standard deviation is much smaller. So he's much, much more consistent. Maybe, if there are teams out there who say, we recognize B is a lot more variable, he'll have some high and some low games, maybe they choose that. So there is a reason maybe for choosing B. You'd have to justify, though. You'd have to say, we know there's going to be some really low games, but there's also going to be some really high games, whereas A is really consistent. So you can calculate it on the calculator as I showed. So here's A's on the calculator if you want to see. There's B's that we obviously did. So there you go. That's how you can find the mean and then what we call the standard deviation. Just going to expand a little bit more on what that is actually telling us in terms of the standard deviation. What it means is this. So running back A, his average was 83. His standard deviation is 5.1. Let's just call it 5 to make the numbers nice. It means on average, if I go 5 above and 5 below, it means most of his games are between 78 and 88 yards. If I go up and look, how many of his games were between 78 and 88? 1, 2, 3, look, 4. The vast majority of his games are in between 78 and 88, right? Over here, though, on running back B, he has an average of 84, but his spread is so much wider. I'm adding 48 above and below, which shows how inconsistent he was. So 132, and then if I go below, I'm going to be at 36, which means the spread of his games can go anywhere from between 36 to 132 in general. So the majority of his games are in that range. It's just a much wider range. So it just depends on what they're after. One more scenario. Let's say a soda company is choosing between 2 machines that fill up their cans. They take a sample of 5 cans filled up by both machines. Each machine is attempting to fill the cans as nearly close to 12 as they can. Which should they choose? So machine 1, 12.1, 11.8, 11.9, 12, 12.1. You can see the data for yourself. In class, I would ask half the room to do machine 1 and half the room to do machine 2. I'm going to show you how you can use Desmos to actually get these values. So let's do machine 1 right here. So what you need to do is you need to get the data set list, and then you go to Desmos. So go to Desmos. I'll show you all the way from the beginning. Click Start Graphing, and this is what you need to do. You need to choose any variable you want. D could stand for data, and then you hit equals, and then you need to do a bracket. If you're entering a data set, it has to be in a bracket, and then you just type in your values. I can copy and paste. Now I go down to the next cell. If I go down to the next cell, and I click over here in this keypad button, there's functions. You'll see there's a stat menu, and in there are values I can calculate. Let's do the mean first. So the mean, and then I type in D for the data set. The average is 11.98. If I want the standard deviation, I go back to functions, stats, and standard deviation we want is this one. Standard deviation P for population. There is a standard deviation with nothing that I don't think we get to in this class. If you take a statistics class, you'll talk about it, but you want standard deviation P because we're talking about population. So standard deviation P, and then you say D, and its standard deviation would be 0.12. So, and then you could do that for machine 2 as well. So you need the mean and the standard deviation, and when you do them, there they are. And then we need to summarize what's going on. Well, if you look, machine 2 is consistently overfilling. If you look at their standard deviations, machine 1 has a slightly larger standard deviation, so it's a little less consistent, but it's not bad. That's actually a pretty small number. The problem with machine 2 is it's very consistent, but it's very consistent in overfilling. So here's how I would interpret the results. So machine 1 has an average of 11.98. Its standard deviation is 0.12, so it means on average it's usually no more than 0.12 above or below its average. So machine 1 fills up the majority of its cans in between those two values, whereas machine 2 fills up the majority of its cans in between 12.31 and 12.21. That's consistently overfilling. All those numbers are all over 12, above 12. So most would probably choose machine 1 because machine 2 consistently has a smaller standard deviation, overfills. Machine 1 has a slightly larger standard deviation, but it is on average closer to the mean. And that is it for today. Thank you very much. Have a good day.